Hi, in the last video we did our first parabola problem. Now we're going to do another. You have to find the focus, directrix and axis again, but this time the parabola is x equals y squared plus 2y minus 4. Now, we're going to use the same techniques as we have in the past. We're going to try and rearrange this equation to make it resemble the standard equation of the parabola as much as possible. We want to rearrange this in such a form that one of the variables, squared, is equal to a constant multiplied by the second equation, the second variable, of the equation. We do that by completing the square, as we often do. We complete the square on this side of the equation because it's clear that y is the squared variable in this case. So x equals y plus 1 squared minus 5. Bring the 5 over to here. X plus 5 equals y plus 1 squared. And you can rewrite that as y plus 1 squared equals 4a times x plus 5. This now resembles standard form. One of the variables is squared, and that squared variable is equal to a constant multiplied by the second variable of the equation. Now, in this case, again, like the previous example, 4a is 1, therefore a is a quarter. In the next example, we'll do an example where a is not 1/4. The next step, as I mentioned in the previous video, was that I often think, what does the parabola roughly look like? We can see that the standard parabola has a C shape. It's a right-oriented U shape. And we can tell this particular parabola that we're being asked to look at is a simple, is a transformation of this graph. It's a transformation of the standard parabola. Hence, this parabola must also have a C shape, like I've drawn here. So we have the basic shape of the parabola. Now, as I mentioned, the first feature I look for is the vertex. The vertex in this case, which I've labeled here, is minus 5, minus 1. How did I get that? Look at this equation here. The minimum value that y plus 1 squared can be is 0. It takes the value 0 when y is minus 1. Hence, I know the y-coordinate of the vertex is minus 1. When y is minus 1, x is minus 5. Hence, the x-coordinate of the vertex is minus 5. What about the axis? As we mentioned, the axis goes through the vertex and splits the parabola into two symmetrical parts. Because we know in this case that the parabola is a C shape, the axis must therefore be a horizontal line that goes through the point minus 5, minus 1, and splits it, like so. If it's a horizontal line, we know that the axis must have equation y equals something. Because we know the vertex is minus 5, minus 1, the axis is going to be y equals minus 1. Okay? So that takes care of the axis. What about the focus now? Remember, over here on this algebraic side of the problem, we said that a is equal to a quarter. We said that the focus is always a units away from the vertex on the axis within the interior of the parabola. So to make a rough drawing again, let's say this is roughly where the focus is, and this distance is a, which is 1/4. If we know the vertex is minus 5, minus 1, and if we know a is a quarter, and we know the focus is a quarter of a unit away, we can find, obviously, the coordinates of the focus. In this case, because the axis is horizontal, it's a unit towards the right-hand side. The focus is minus 5 plus 1/4, comma, minus 1, which is minus 19 over 4, minus 1. You're moving across in this case, unlike the previous one. You're moving across because the axis is horizontal rather than vertical in the previous case. The last feature, the directrix. Again, remember we talked about the directrix being a units away from the vertex, but in the exterior of the parabola. And we said the directrix is always perpendicular to the axis. So if the axis is horizontal, the directrix must be vertical in order to be perpendicular. This distance is again a, which is 1/4. What is the equation of this directrix? It's vertical. So we know that the equation is going to be x equals something. We know the vertex is minus 5, minus 1, and we know the directrix intersects a point that is 1/4 away, 1/4 unit to the left of the vertex. Hence, the directrix's equation is going to be x equals minus 5 minus 1/4, because it's on the left-hand side, which is equal to minus 21 over 4. Alright, that explains now how we got the 4 features. We're going to do one more problem where 4a is not 1, and then we'll move on to the next concept, which is ellipses. Thank you for your time.